Hello friends, and welcome to the Festive Tech Calendar 2023. My name is Callon Campbell, and today I'll be talking to you about Azure Durable Functions, the festive magic of scalable serverless workflows for the holidays. So my name is Callon Campbell, and I'm Microsoft MVP for Azure. My passion is with serverless technologies, with cloud native, and everything, pretty much everything inside of Azure. Um, Today, I'll be talking to you about serverless durable functions. I'll be starting off and do a quick serverless refresher for those that might not know. And then I'll speak to some of the challenges that serverless brings and how durable functions can solve those challenges. I'll then talk about some different storage provider options. And I have a bunch of demos scattered throughout all the things, and then we'll wrap up. Okay, so what are Azure Functions? Azure Functions are event-based. Basically, they will scale from not running to thousands of instances and back down as needed. There is no infrastructure management that you need to worry about. So just because it's serverless doesn't mean there are no servers, but it's nothing that you need to manage. And basically, as it scales, you're only going to pay for what you use. Caveat there depends on the pricing plan that you go with, but with consumption, pricing is pretty much free for. It's free. Yeah, you really have to abuse it to start paying for that. But it goes all the way up to premium plan, which can be used for enterprise. Okay, so Azure Functions are everywhere. It's open source, which includes the runtime, the core tools, and Docker images. You run it locally, so knowing it's exactly what you're going to see in the cloud, and it's very easy to get going and publish. There are 3 different hosting options available. So you have the consumption plan, so that's like pretty much the free tier. It will scale as needed. The hardware is probably not the best. It does have cold starts that you need to deal with. It doesn't have all the enterprise and security benefits that you would want to get. So for that, you would want to go with the premium plan. That does provide like VNet support. It does have mitigations against cold start. It does have much better hardware behind the scenes that you can use. And there's also app service plans. So if you want to take your function app and just run it inside of an existing app service, you can do that. So premium plan sort of brings the best of both worlds between the consumption plan and the app service plan. At the Ignite conference earlier this month, they did announce the Flex consumption plan, which is a new thing, a new plan that you can opt into. It is in preview currently, but it's kind of like some of the benefits that the premium plan bring, you can have now on the consumption plan. So if you're interested in that, you can go ahead and sign up and request access to that preview. Outside of Azure, you can run functions on IoT devices like Raspberry Pi. Additional hosts can be an AKS. And then you also have the non-Azure hosts, so you can run it on VMs on-prem. You can run it into another stack if you want, or even on the Azure stack. So in Azure Functions, you have 2 hosting models. You basically have the in-process. This is the hosting model that Azure Functions started with. Your code basically runs inside the same process as the function host. It only supports the LTS versions of .NET, so the long-term servicing branch. So think like .NET 6, .NET 8, .NET, I guess before 6 was what, 3.1. So all the long-term servicing. The isolated worker is a new process that was introduced with .NET 5. And what they did is they brought this about so they could start breaking out from the in process and start iterating much quicker and the other benefits are coming up in a second, but anyways, the isolated worker is the future. It is where it's the default right now if you want to create an Azure function in .NET 8, which just came out earlier this month. The isolated worker is currently the only process that's available right now. The end process will be coming out sort of later for .NET 8. And then after .NET 8, the .NET team says the isolated worker is the only hosting model that they're going to support going forward. So what are some of the challenges of serverless? So we have some sequencing where we have functions that want to call other functions and move around. So as you know, functions is a stateless environment. So how do we manage that state between each of the function calls? We have fan out and fan back in pattern. So if you want to do some parallel work and then pull the results back in, that can be challenging. Third, we have external events correlation. So waiting for something to happen externally and acting upon it. You might want to have long-running functions, including long-running HTTP-based APIs. And last but not least is human interaction. So maybe you want to wait for some human decision. You don't want to wait forever, so you do want to have a timeout. So let's look at two of these patterns. So I'm going to look at pattern number 1, which is function chaining, and then we'll look at pattern 2, which was the fan out and fan back in pattern. Okay, so function chaining. So what are some of the problems? So basically, there's no visualizations to show the relationships between each of these functions and the queues. So often enough, you stand up a queue. So function 1 runs, the output of that will go into a queue. It then becomes the input to function number 2. Function 2 runs, output of that goes into another queue, and so on and so on. It gets very hard. One, you have to manage all these queues between each of the functions. And 2, you don't have a visual representation of what's going on in your system. And error handling here can be much more, had a lot more complexity. Okay, with pattern number 2, fan in and fanning back out. So fanning out is quite easy, but fanning in is significantly more complicated. So durable functions today offer help, or functions today, I should say, offers help with the scenario today. And this also has all the same problems of pattern number 1. So now I have to put in some queues to manage the complexity instead of letting the functions handle this themselves. So durable functions were introduced a few years ago. It's an extension of the Azure Functions, and it's built on top of the Durable Task Framework. It allows you to write long-running, reliable, event-driven, and stateful logic while simplifying complex stateful coordination in your serverless applications. The execution state is saved in Azure storage account. This ensures that the functions can recover automatically from any infrastructure failure. And it's ideally suited for situations where you want to chain functions together, or do the fan out and fan in pattern, or run HTTP asynchronous APIs that might be long running. Maybe you're monitoring or waiting on user interaction. With the durable functions, they automatically checkpoint their progress whenever a function awaits, and the local state is never lost if the process recycles or the VM reboots. So if that does happen, the function will just pick up where it left off. So durable functions basically allow you to simplify complex and stateful coordination requirements in the service applications, and it takes that away from you. So you don't need to worry about that. Support is for .NET, so you have C#, F#, just Java, JavaScript, TypeScript, Python, PowerShell. Pretty much all the frameworks will support durable functions. So again, if we go back and look at the patterns, the primary use case for durable functions is to simplify, the complexity of stateful coordination requirements in your serverless applications. So it will cover function chaining, the fan out, fan in, asynchronous HTTP APIs, monitoring, human interaction, and aggregation, which is stateful entities. I'm not going to talk about stateful entities in this talk, but that's another aspect of durable functions. So the components of durable functions. So what makes it up? So if you're familiar with Azure Functions, you have your function application, and then inside your function application you have functions, and your functions can be HTTP trigger functions, they could be queue functions, they could be event hub functions, Cosmos DB functions. So there's all kinds of triggers functions can be vented on. So with durable functions, they basically added in 3 new function types. So you have your starter function. So this is what will go and start the orchestration. You have the orchestration function itself. So this is the one that will manage and keep track of all the state of what's happening. And then you have your activity functions. Your activity functions are the ones that actually go and perform the work. So think of the activity functions as a traditional function in terms of what they're doing. This is where you do all your actual work. So the orchestration function is literally, as it says, it's an orchestrator. And when we get into the code, you'll see that's pretty easy in terms of like, you're not building something very complex. It's just writing normal code, C# or whatever language you're in. And all that complexity, all the state that's managed, it's all abstracted away and handled for you, which is awesome. Okay, so with durable functions, it uses a pattern called event sourcing to store the state in a backend storage account. So by default, Azure Storage uses an Azure Storage account, and this is where it tracks all of the state. So if you're running locally, so as the screenshot shows here, yeah, it's a bit old, but it's a good screenshot. It's showing, when I run my function application locally, I'm using my local storage account emulator on my machine. Durable functions will automatically go and create all the tables, the queues, the containers, whatever it needs to do its job, and all that state is managed for you. You don't need to go in here and look at all the data. You can if you want to. It's best you don't go in and muck with it. If you really want to see the state of what's going on inside of your orchestration, there are better tools like the Durable Function Monitor. It's another tool you can go download from GitHub. I'll provide a link in the end of my slides for that if you're interested. So how does Durable Function work? So I'll just run through the simple 3 lines of code and I'll show you how each of the different functions interact with one another. So we have our code, var outputs, we have a new list of strings. What we're going to do is we're going to say hello, and we're going to do this for Amsterdam as a city. And then when we're done, we're going to return back the outputs. So what's going to happen is we're going to start off, orchestration function is going to be triggered. So it's going to get triggered by the starter function. So starter function, in this case, could be an HTTP trigger that starts the orchestrator. It could be a queue trigger, however you want to launch this, you can trigger your starter, which will launch the orchestrator. So the orchestrator will run. It will scan through the code. So it comes up to the first one, which is outputs await, and it's going to call this activity async, and in brackets say hello. So that's the name of the activity function called say hello, and it's going to pass the data Amsterdam. So it's going to go and it's going to check the event source execution history. It's going to say, have I run this activity before? Answer is no. So it's going to go ahead, call the activity function. At this point, the orchestrator is going to go asleep. It's completed its job for the time being. Activity is going to run. Now it's going to print out hello Amsterdam. And now the activity function is done. It's going to return back its output. The orchestrator is now going to wake up So you're not paying for both. They're not both running it simultaneously. Only one is ever running. Orchestrate is going to wake up. It's going to go run the next code again. It's going to say, have I run this? It's going to say yes. The result was Hello Amsterdam. Orchestrate is then going to proceed on to the next one. If there is more activity functions that need to be called, it will call it. And it will just go back and do that whole loop again until it's done. But at this point, there is nothing else. So the end is return the output, which is Hello Amsterdam. Now the orchestrator is completed. And that was very, very simple. I'll show you this when I get into actual demos, how this is working. But just from a very high level, I wanted to show just how that is working. So some of the constraints that an orchestration function has is that the code must be deterministic. So it's always going to run. It's always going to go back to the beginning and rerun again. And it's going to determine which activities it's called and which ones it still needs to call. So in the orchestration, you never want to use random numbers. You don't want to use datetime.utc now or new good, things like that. So there are ways to do that. So you can use a durable orchestration context, .current UTC time, for example. Your orchestrator should also be non-blocking. So you don't ever want to do any I/O directly in the orchestrator. So what you want to do is you want to do that I/O inside your activity functions. And you also don't want to write any infinite loops. So where the scenario where you want to have an infinite loop, then what you want to use is the durable orchestration context continue as new. So when your orchestration is done, it will just continue and run itself again. So it doesn't go back to the beginning, but it will just create another instance of it and keep running. Okay, so that brings me to demo number 1, function chaining. So just a heads up, all of my demos, let me go to, so what I've done now here, little housekeeping for my demos, is all my demos are in Visual Studio 2022. I'm using .NET 8, and I'm using the isolated process model. That's the only thing that's supported in .NET 8 at this time. So I have 4 different demos that I'm going to run through. What I've done in my GitHub repo, if you're following along and you come along later and you want to see this, is all of my demos are just different branches in my code. They all build on top of each other, so you just start out here and you can see what happens between each of the different demos. So that's how I'm going to be jumping around, just so I'm not writing code on the fly, because we all know what happens when you try to do that live during a demo. The demo gods are never happy about that. Okay, so this is demo 0. This is just out of the box. I'm creating an Azure function. So I'm going to show you just what does that look like. Create a new project. Okay, Azure Functions. Yeah, I'll call it function 1. Okay, these are my options. I have .NET Framework 1, I have .NET 6, I have .NET 6 isolated, I have .NET 7 isolated. .NET 7, .NET 6 and .NET 7 don't really have support for durable functions, so don't use it. .NET 7, they kind of added support, but considering that .NET 8 is out now, I would just move to .NET 8. But otherwise, .NET 8 isolated has full support for durable functions. And then you also have .NET Framework isolated v4. Don't know who's using that, but it's great that all these different frameworks are still supported, which is awesome. Okay, so I'm going to stick with .NET 8 isolated. I will just go vanilla and do a HTTP trigger out of the box. I'm going to use Azurite for my runtime, and I will change the authorization to anonymous. Don't want to worry about that for the time being. The other options that you do have, so you can use function, which is what the default was, and then you can use admin. So these are just little tokens that are created, and when you deploy to Azure, you can manage how you call it. There are better ways of doing this. which is why I always go with anonymous, but you have those options if you want to choose a different authorization level. Okay, so I'm going to create. Of course, I get squiggles. There we go. So this is my function. Again, I said I wanted an HTTP trigger function, but what I'm going to do now is I'm going to go ahead and add a new function called new function. I'll call it the durable. Okay, I'm going to scroll down. I'm going to pick durable functions orchestration, and then I'm going to add that. So you can see here I have my function one, which was the one that came out of the box, which is just an HTTP request. And then when I go into my durable function, it's gone ahead and added 3 different functions for you. So you have your starter function, which is basically an HTTP trigger. And what that will do is it will go and schedule a new orchestration, give it the name of the function, so it's called durable function, is what I created up top. And it's going to go and run that. And then it's going to return back immediately a check status, and I'll show you what that looks like. So if this is a long-running function, then immediately you'll return back the status of how do I interact with that function. So how do I terminate it? How do I get the status? How do I send new information? And there's 1 or 2 more. I forget now. Go figure. Being on demo. Okay, so that's your trigger. So this is going to start it. And then we have our orchestration. So called in this case, it's just called durable function. It's my orchestrator. And what I'm going to do here is I'm going to call this say hello. I'm going to pass in 3 different city names. And say hello is basically, this is my activity function. So you can see like they all look like normal functions. And really the only difference here between them is in my activity function, I have this thing called an activity trigger. And the context will get passed in, and then whatever data is coming in, so in this case is name. In my orchestration function, I have the orchestration trigger. Again, the context is passed in. And then if I go back to my starter function, basically, HTTP triggers how I'm triggering this. This could have been triggered off of really any standard function like a queue trigger, Cosmos DB trigger, whatever you want to trigger these your durable functions to trigger off of. But basically inside of that function, you're adding the durable client and then your function context. Okay, and that's how you're interacting. So this is what comes out of the box. These are all just static. It's not what I would call best practice for standing up a durable function. So that is my new function out of the box. So as you can see here, the one that I have checked into source code, very, very similar. So I have my HTTP trigger, just say hello, and then I have my hello durable. Again, everything's identical to what I showed you when you say new durable function. Okay, so I'm going to go ahead and undo all these changes. Undo changes. Of course. Delete. Okay. So moving on to, let's see, demo 0. Did I cover everything off? Yes. Okay, so next demo, I'm going to run through about 3 demos back to back before I go back to slides. So I'm going to move on to demo 1 now. So demo 1 is basically, let's take the previous demo that I showed you, the box one, and let's just improve upon it, sort of some best practices that I like to follow. So as you can see here, and it's going to complain about all these things. Close all, delete those. Okay, so what I've done here is, I haven't changed any code here. So everything out of the box, my program.cs where I'm doing my dependency injection, etc. That is the same throughout all my demos for the most part. My host.json, my local settings, those do change. So they haven't changed yet, but I will call out what changes in them. But what I've done in demo one now to showcase some best practices is if we go to my function, all of my functions now I'm using name of. So instead of doing the hello, in the starter function where it was called HP start. So what I've done is gone and renamed them all just based off of the class name. That way, if you ever go and rename files, rename your classes, you're not having to go and fart around and fiddle around with renaming strings after the fact because they don't change right away. So that's number one. Number two is I've gone and split up all my functions into different folders by type. As you start building your function application, you start adding more and more triggers. You want to be able to see which kind of functions that you have more easily. So I split it up into an HP trigger folder. So I have my welcome, which is just say hello. And then I have my starter function. And then I've gone and created the durable functions folder. In there, I've broken down to activity and orchestrator. So if I go my starter function, again, everything here should be identical other than I've moved it to different files and I've cleaned up the naming convention. I also got rid of the static class and I set up my logging appropriately. That should be the only changes that you would see. Again, since this is Festive Tech Calendar themed, I've gone and changed it from cities and over to the reindeer, Santa's reindeer. So we're going to say hello to each of them. And, when I go to my activity, again, it's just saying hello to some name. So what I'll do is I'll go ahead and run this function now. Okay, so my function has started up. You can see here I have a welcome function, which is HTTP based. So the orange are HTTP based. So get and post are what's supported. Here's my local host, port 7225, and then API welcome, and then API starter. I then have my activity function named activity trigger, and then I have my orchestrator function named orchestration trigger. So using a tool here called REST client in Visual Studio Code, all I'm going to do here is simulate some requests to this API. So I'll do welcome. So you can see here I got back 200K. Welcome to the Festive Tech Calendar 2023. My orchestrator here, I'm going to delete that because that's old. So what I'm going to do is I'm going to start my orchestration, and I'm going to basically go and I'm going to call the starter function to start that. So you can see here in the background, it's gone and it's running all kinds of things in the background. It's immediately returned back to me a 202 with the following response. So these are all the check status of what's going on with your function, and this is how you interact with it. So this is the ID. So the ID is something I created for it. You can create your own IDs. If you don't give it an ID, the system will generate an ID for you. It needs to be unique. It then gives back a bunch of URLs. So if I want to go purge the history, I can call this this URL. And URL is just basically made up of you're hitting the runtime, you're interacting with a bunch of webhooks, and you're going to pass in the the ID. So you can see here, here's my ID. Okay, and then you're going to pass in a code. Again, this is inside the code. It's nothing you need to worry about. It's all being done by the framework, but here's my code that's passed in. And if you want to do this inside of when you publish it up to Azure, these can all be made available to you, and you can put in different codes as you like. So what I really want to do is I want to see the status. So what's it currently doing? So I'm going to copy that, and I'm going to come down here, remove that old instance, paste in that, and okay, so there's that. I'll close down my response. Okay, so here's the response coming out of that orchestration. So the orchestration has been run. So you can see here the name of the orchestration. It's called orchestration function. I'm sure you would give a better name in a real world scenario. Here's my instance ID. You can see the status. So if this was still running, you would say running. If it hadn't started yet, it would say waiting. In this case, it's completed. If it was an error, you could see that. You can see what input was passed into your orchestration. So in this case, none. Custom status is something that you can go and set. So if it errors out, you can go put error details into the custom status. But here's the output of my function. So I've gone through and said hello, Dasher, Dancer, Prancer, Vixen, Comet, Cupid, Donner, Blitzen, and finally Rudolph. I can see when my orchestration was created and the last time it was updated. So again, as it goes and checkpoints everything that it's doing, that last updated time gets updated. So again, this is a very, very simple use case, so it completes very, very fast, but you could have very long running durable functions. So you could have it, processing maybe processing orders. In that case, it takes data in, processes it, maybe it wants to drop a file into storage, maybe it needs to call a number of third-party APIs. You can build in a number retry patterns, so if I'm trying to call a third-party API and it's down, maybe I'll wait and retry again. So there's a lot of things that you can build into your durable function very, very easily without having to build complex code to do it yourself. And when your function is finally done, you can call and get the final output for it. Okay, so I think that covered everything I wanted to show in demo number 1. Okay, and then let's see, under the project itself, so package references, if you're using .NET 6 and you are migrating to isolated, basically your package references are going to change. That's the main difference. You're going to say, .NET 7 or .NET 8, whatever you're migrating to. In this case, if I'm going from .NET 6 to 8, you would see .NET 8 up here. Your package references, pretty much all of them are going to change. Even if you download and install the tool, the Upgrade Advisor, where you can upgrade, it does like 99% of the work for you. I find on some more real world projects, you need to clean up and remove some packages that aren't needed, are no longer needed. As a caveat, just be aware of that. Again, the other thing that would change is, not there, inside your local settings file, the functions worker runtime, it's going to go from .NET to .NET-isolated. Let's see, what else can I show you here? Durable Task Hub name, I think I accidentally put that into this demo as part of the next demo, so I won't speak about that right now. So anyways, I know there's no live audience, so I wish I could answer questions. If there are questions, please reach out to me after, my details are in the end of the video. I'm happy to answer any questions offline after this video is released. Okay, so let's go now to demo number 2. Okay, so demo number 2, nothing or very little change. So same project. This one is all about configuration. So hence these two things. So what I've done is we go back into our functions. Okay, so we go to my starter function. So now instead of hard coding, my durable task hub name, so it will generate one for you if you don't specify it. But a lot of time you do want to best practice is specify what your task hub name is, because what happens when you want to update or deploy a new instance of your application. I'm not going to cover that in this talk. There's some great documentation on Microsoft Docs that goes more into detail on that. You might want to run side by side two different versions. You might want to change the task hub name. So I find a good practice just to specify what your task hub name is. So what I'm doing here is inside the percent brackets is my variable name. It's going to go to my settings file and basically just look for that. So here's the name of my task hub. So that's on my starter function. Nothing else changed here. If we go to the orchestration now, nothing has changed there. And if we go to my activity function, nothing else has changed there. So, but there was two things that I added. So the other one was my storage account. So if we go to our host.json file now, so what I've done is I've explicitly called out, so this wasn't here, if I go back to the previous demo, I didn't have extensions and call out any configuration. So it's using the defaults. So what I've done now in configuration is I've just explicitly showing you these are the defaults. You can go and change them however you like. So you can see here, here's the task hub name. It's going to pull that in from configuration. And the other thing here is the connection name. So when you create an Azure function application, it wants to create a storage account for you. If you want to go and create many function applications that all share the same storage account, you can go do that. It's advised not to do that as the best practice. Again, that's covered in Microsoft Docs. Typically create a separate storage account. Storage is cheap. It's treated as a black box. So the function framework needs it. Give it a function storage account for itself. If you need a function, or if you need a storage account for your own business needs, create another storage account where you put your business logic for queues or containers or whatever you're using inside that storage. But give the function itself its own storage account. And when it comes to durable functions, it also recommends that the durable function gets its own storage account. Specifically, this is a bit old. I don't think it still applies because version 1 of general storage is gone away, or is still in the process of going away. But at one point in time, it was recommended to use V1 of general storage versus the V2 because it gave better performance when it came to durable, how it's being used. So in this case, I'm just calling out, use a separate storage account. So if I come to my settings, you can see here, I'm just using local storage for both. But in a real world scenario, when I deploy this to Azure, I would probably give this 2 separate storage accounts use. Okay, I think that's it in terms of this demo. Let's see, host config. Yeah, so I think that's all I wanted to cover in this demo, just showing you the different configuration options and just what I've done. Okay, so now we'll move on to the third demo. So third demo now is I've created another function application. So the first one was function chaining, just saying hello to all the different reindeer. The demo number 3 now is I'm going to do the fan out and fan in pattern. So for demos, I like to use the Star Wars API. I'm a Star Wars fan. And Star Wars API is just a free API you can go use, swapi.dev /API. And basically, it's just an API you can go iterate with. So in this case, what I'm going to be doing is just using that API to showcase function, the fan out and fan back in. Okay, so if we go look at our host file, I left the storage as is. Just explicitly called it out. Okay, if we go local settings, pretty much I changed the name of my task hub to 3, demo 3 to match it. And then I added another one, the Star Wars base URL. Again, if you're new to functions and you need to deploy your application up into Azure, you don't actually deploy this local settings file. This is just for you running locally. you would go set all these as environment variables inside of the Azure portal, or use Azure app configuration. And if you had secrets, I would use Key Vault for that. So there's lots of options when you get into the portal of how you want to do this. I think in this one here, I explicitly called out logging, app insights, and in this case, now we're using an HP client. So the program.cs changed a tiny bit versus the previous ones. If you go into our functions, so again, I have my welcome, I have my HP starter. So in my starter now, I've made the function that I want to start, I've made this a little bit more robust. So it's not hard coded to call. Let's see, what's my orchestration called? It's not hard code to say get planet residence orchestrator. So if I add another orchestrator in, I could use this HP start and pass in the name of that orchestrator. So this is a little bit more dynamic. I will take the input that I'm going to be passing, which is a parameter. I'm going to pass that in to my orchestration. Other than that, I'm just pretty much creating the same orchestration as I've done before. That's the only change. Okay, so now if we go to my orchestrator, so the idea of this, let's see, let me go to my sample API. Okay, so here's my API. Yeah, you guys see this. Okay, so what I'm doing, so here's all the APIs that Star Wars API is supporting. And so what I want to do is I want to say pass in a name or partial name of a planet, and I want to find out all the people that live on that planet. You know, I can then, you know, from that planet, I go find out, you know, all the species, all the vehicles, all that kind of stuff. But in this case, I just want to do people. So you can see these are the type of APIs I could be calling behind the scenes. So in this case, I'm going to pass in TAT. I'm going to look for tattooing. You know, I don't have to pass in the full name. I can do partial. And then I'm going to go look for people. So you can see that down here, I'm passing in the name of my orchestrator. And here's the content type. So it's a post. You know, and then we'll come down to the orchestrator to get the status of what it's doing. So that's what we want to do. So if I look at my get planet residence orchestrator, what I've done in this one versus previous demos is I'm now showcasing context that is replaying. So remember in my slide when the orchestration started up and the little cursor moved down and then went to the activity, the orchestrator went to sleep, and then the activity did its thing, and then when the activity was done, then control was passed back to the orchestrator. The orchestrator started back at the beginning, so right here, and then it would go down. It would say, have I done this? Have I done this? Haven't I done this? And it would just keep going until it finds the next place it hasn't done something, and it would then start doing that activity. So what you want to do is I don't want to keep logging every time the orchestrator starts back up. So if it's not replaying, then I'm going to log, okay, I'm starting this instance. But every time it then comes back and it is replaying, I don't want to do this logging that I'm doing, okay? So that's why you would want to do this. So otherwise I'm getting my input, so planet name, it was passed in. Now you can see here, call activity. I'm going to call the planet activity is what I'm going to get back. I'm going to call this search planet activity, and I'm passing in the planet name. If the planet name is, or that result is not null, then I'm going to do a for each, and I'm going to call this activity, and I'm going to get all the characters or all the people that are from that planet. And then when all done, so this is the fan out. So for each, I'm fanning out. And then when all those tasks are done, I'm going to fan back in. And then I'm going to get through my results, and I'm going to select that as my output of my orchestrator. Okay, and if you go to our activities, so the first one was search planet. So both very, very similar. I'm just going to make an outbound HTTP call, look for that planet on that API, get the result back, serialize it, and same for get character. Again, call the same Star Wars API, pass in the character. So there's actually a URL for that character on that planet. I'm going to pass in that and then get the result. Okay, so let me run this version now. See how am I doing for my notes. I think I'm good. Okay, still building. It's almost ready to go. Should have got some Christmas music play in the background while I wait for Visual Studio to build. Okay, come on. This is taking unusually longer to do. Why? Because I'm videoing, that's why. Why else would it do that? Build, cancel. Come on. Rebuild. Okay, I don't know what's going on. Close it down, bring it back up. Gotta fix that. Okay, let's try running that again. There we go. Put that over there. Okay, so we have my HB start, my welcome, my 2 activities, and an orchestrator. Okay, so I'll hit the welcome, make sure that's working, no problem. Okay, I'm gonna run my orchestration now to say get planet resident. So I'm gonna pass in Tatooine. Did I not click on that? Probably not. Okay, so there's my, you can see that here's my output, and you can see in the background it's running a whole bunch of things. Put that down there. Okay, and then we'll get the status. It's probably done by now. Okay, so there's my orchestration. So it is completed. So you can see now here's my input. I passed in Tatooine. I'm doing a simple string here. I could pass in a much more complex object if I wanted to. You can see my output. So I've looked up planet Tatooine. The residents are Luke Skywalker. We can see all the films that they've been in. So here's all the URLs. You know, C-3PO, Darth Vader, Owen Lars, Beru, R5, Biggs, Anakin, and Shim Skywalker, and Clive Lars. Okay, so those are all the people that are, at least this API is saying, that reside on Tatooine. So there's my fan out and fan back in as an example. Okay, so I think I showed everything here that I wanted to show, including Visual Studio hanging on me, unscheduled. So let's go back now to, so demo 4 is storage. Okay, so let me go back to my slides. Continue from current slide. Okay, so we did demo 1, function chaining. We did demo 2, configuration. Demo 3 was function the fan out, fan back in. Okay, so this is the last thing I want to talk about in my presentation. So in durable functions, you know, when it was first announced, Azure Storage was the default. Right now, Azure Functions, or sorry, Durable Functions offers several storage providers, also called backends, for storing the orchestrations and entity runtime state. So by default, new projects are configured to use the Azure Storage provider, but you also have two other options. So first is Netherite, and the second is Microsoft SQL Server, including full support for Azure SQL Database. So support for the two new backends was announced, I feel like 1 or 2 years ago, maybe. Anyways, they went GA last year, and what they do is, one is a Netherite, so that's the one I'm going to be covering in more of a demo perspective, and the second is Microsoft SQL Server. So with these new storage options, you have you can run at a much higher rate of scale. You have a greater price performance efficiency, and you have greater portability compared to just using Azure Storage. So if you're just using Azure Storage, you are pretty much stuck inside of Azure. So I'll cover what you can do there. So limitations of Azure Storage provider. So it has following limitations. So limits on the number of transactions per second that it can process. It has strict data size limits for the queue messages and for the Azure table entities. It's hard to predict the costs in terms of number of messages and throughputs that are going to be happening. It also doesn't easily support enterprise business continuity requirements, such as backup, restore, and disaster recovery without data loss. Azure Storage is also Azure only, so there is that. So again, remember when I did the intro about serverless and Azure Functions, you do have the option of running Azure Functions outside of Azure. So Raspberry Pi, other clouds, on-prem, right. And so how does that work? Obviously, you can still plug into Azure and use a storage provider, but now you have code running over here, and then you're calling a storage account. I hope that's on camera. But anyways, you have your code here, and then you have your storage account over there, not in the same place. So not ideal. So first is Netherite. So Netherite, as the name suggests, comes from the world of Minecraft and is the name of a rare material that is more durable than diamonds, can float in lava, I should say, and cannot burn. Netherite storage provider aspires to the very same qualities, but in the context of durable functions. So Netherite was developed by Microsoft Research. It combines Azure Event Hubs with the faster database technology that sits on top of Azure Page Blobs. So Netherite supports significantly higher throughput and is more cost effective for high throughput loads. So to demonstrate that, we have a performance benchmark. So again, this is coming from the docs. And I'm going to actually demonstrate this in my next demo. So you can take a single Azure Event Hub throughput unit. Typically it costs about $22 a month USD on the standard plan. And I can running the simple function chaining demo of 5 activity calls. So let's say the hello cities, passing in 5 cities. And if I run that on the Azure Functions Elastic Premium plan, so it's going to run really fast, you can see here in blue that regardless how you scale up in terms of Elastic Premium, whether it's EP1, EP2, or EP3, you're pretty much getting the same throughput. You know, you're almost doubling, I guess, if you're going from 10 to 1800. But it's still pretty flatlined in comparison. So when you look at durable tasks netherite, you know, you're getting substantial increase in throughput. You're going from 2000 to 26, much, much higher. And again, these are events per second, so really, really fast. Okay, and the other option is SQL Server. So if you already have, you know, in enterprises, you know, the odds are you probably have an Azure you probably have a SQL Server. It doesn't have to be Azure SQL, but it could be any SQL Server. It could be on-premise, could be Azure SQL in the cloud, could be in Docker, Kubernetes, could be IaaS, could be multi-cloud, could be in AWS, GCP, wherever you're running this. And you might be saying, well, Callon, what about Azure Functions? Doesn't that need to run itself in Azure? And the answer to that is no. You can run Azure Functions outside of Azure. Using Kata is what you would use to host that outside. I haven't used it myself per se, so I'm probably getting some of the terminology messed up on that. But yes, you can run Azure Functions outside of Azure. You might lose a small percentage of functionality, but for the most part, it is there. And the Azure group is constantly iterating and improving that. So by using Azure SQL Server as your backend provider for durable functions, it allows you to leverage your current investment in SQL Server, so no additional cost for the most part. So you get to leverage backup or stores, you get to leverage failover, encryption, compliance, and you can easily integrate with existing SQL-based applications. So when you run your applications and point it to a SQL Server, the durable function framework will automatically create whatever tables it needs inside of that database that you pointed it to. And you can go in and select star, read the data, kind of like what I was showing you in that screenshot earlier for the event source, where you can go into your storage account and look at the queues and the containers and see where the messages are. It's doing the exact same thing, but inside of SQL Server now. Okay, so demo 4 is netherite. So let me stop that. Let me switch over to my demo 4. How am I doing for time? I think I'm okay. Yeah. I'll be done quick, so not much more longer. Okay, so number 4, demo 4, no code change. Okay, all they've done is inside of my project is I've added this package reference. So Microsoft Azure Functions, Worker, Extensions, Durable Task, netherite. Okay, if you're doing this from .NET 6, it's a different package reference, so just be careful of that. Otherwise, that's all you need to do, is you need to, well, I shouldn't say that's all you need to do. From a code perspective, you just need to add in this package reference. There is no actual code change. And then from a configuration perspective, let me start with host.json. So what I've done now is under storage provider, so the previous one said Azure Storage. Now it says netherite. And in the docs, you know, if you want to put SQL Server here, you can go see exactly which types are needed and what parameters are required. So this is the bare bones. I put in netherite, I put in the partition count of 12. If we go over to, we'll do that in a second. I'll bring that in. Okay, and then I given my connection string name is durable management storage, and then my event hubs connection is that. So if we go over to settings, this I've crossed out, but if I took out the X and I went like this and I use single host, it's going to run it locally in sort of an emulator of event hubs. So it's not really going to use event hubs, but it's going to emulate it. The other option you have here is in memory. Go to definition. Let's see, is it going to show me? No, it's not going to show me. Okay, so if you go to the docs, the other one is in memory. That one there. So a single host, if I stop my application and restart it, it's going to pick it up. It's not going to lose anything. If I do memory and I stop my application and I restart it, everything's wiped. It's going to rebuild them in memory again from scratch. So in this case, I'm not using that. I'm actually going to use event hubs. So for the purpose of this, where is it? User secrets. So here's my actual event hubs connection. The whole thing's not shown, and I'll change the key anyways. But you can see here I'm pointing to an actual event hubs connection. I'll bring that in now and just show you. So here's my FTC 2023 Event Hub namespace. In there I have my Event Hub. I have no activity currently going on. So I'll come back to this after I start running my demo. And if you go here, again, these are all my docs in the end of the presentation, which I'll make available in my GitHub repo. But anyways, here, very good documentation in terms of how you configure it, depending on which framework, emulation, what the limitations are, caching, you know, what values you want to use when using, you know, number of partitions, etc. So we'll come back to that after. So let me run this. Again, so the only code changes I did in demo 4 were in my project, I added the netherite package reference, and my host file, I changed the storage provider to netherite, and I added in the appropriate configuration for that. And then in my local settings file, I added in, well, you don't see it because it's a secret, but I added in my event hub connection is pointed to the actual event hub connection string. It's not using this because I renamed it. Okay, so I'm going to run this now. It's going to do the exact same thing that I did in the last demo. It does run slightly faster. Again, this thing doesn't do much. So we're still talking about milliseconds, but it is running faster. And if I were to deploy this into Azure on the premium plan and put load, like significant load on it, then you would see the difference between storage and netherite. Okay, let me go back to this. Get rid of that. Okay, I'll run this again. Here's my status. Okay, run that. You can see, again, came back very quick. I guess I should have tracked what the difference is between that and that, but we're talking milliseconds here. So, you know, this one is faster, at least 50% faster than the other one. Again, my function is running locally on my machine, even when I'm going to Event Hub. So I will simulate some load by just running this many, many times. As you can see, I'm just constantly clicking, generating a whole bunch of orchestrations, clicking as fast as I can possibly click. They're all happening back there. Okay, now if I bring back Azure Portal, hit refresh. This is going to take still running, but you'll see this jump up. So number of requests will go much higher than 16 as it finally catches up. Okay, while that's doing that, let's see what else did I want to show. Okay, so my presentation, all my demos, it's in my GitHub. So GitHub /Callon Campbell. All my presentations that I've done historically, they're all up in there, but just look for 2023 Festive Tech Calendar. The link will be in the slides, the presentation, which will be in this folder here when I upload it. And again, my contact information is inside the slides, so if you you want to reach out to me and ask any questions, I'm happy to do so. This thing's still not refreshed yet. Come on. There we go. So you can see like this spiked up to, number of requests going up, 400. You can see in the background it's finally stopped processing all of them, but again, I'm hitting a third-party API. I'm doing it for, get the planet and go through all the people and get all the details about those people. If I wanted to, if I had a third-party API that was very, very slow, maybe it was flaky, yeah, it does happen. Not everyone's API is gold. Then I could go and put in some retry policies. So when I call I should have put this in my demo, my bad for not doing it, but it would have complicated it some more, is when I call my activity here, I actually have the option to pass in some options, and one of those options are some retry policies. So I can define a retry policy, and what it will do, it will, let's say, try calling this 3 times. I can define what the duration is between each call, what the back off policy is at the end of trying 3 times and fail. The other thing about orchestrations is if it fails here, then the whole thing fails. It's not going to keep going. So it's one thing you need to be mindful of, is trap your exceptions, use the custom status, and put in the details so that when you do need to troubleshoot, it makes it much easier to go and do so when you can go look up your activity and see all the details. And then when I say look up the activity, you know how, I stopped it. Okay, so you know how, let me go back here to, here's an example. So you know how here my output, so I can see this is my input, right? This is my output. Custom status is null. If this was an error, I would have put in details about what the error was. But then if I was doing retries, you would see each of the activities. You don't see it here in terms of output, but there is a way when you go into the orchestration using those back-end webhooks, you can get a lot more detail about what's going on inside of the orchestration. So you can see exactly which activities it called, what the output of those activities was. So you get more debugging information, which is handy. So I might actually follow up and do a blog post or a video on that. Anyways, something for you to go look at. Okay, so I think I covered everything that I wanted to cover. So let me go back to my slides. Demo 4. Okay, so in closing, so Azure Durable Function makes managing state and complex workflows very easy. Something to keep in mind is the input and output of your function should be serializable. Your orchestration function can only call activity functions inside the same function application, so you can't call out to another function app. Don't use an orchestration function just to call a single activity. Like I guess in my demo, well, it wasn't my demo, but like if you're just having one function call one other function, then this is a bit overkill. This is more useful for bigger scenarios. So keep your orchestration small and concise. Again, it's just there is no UI of how it's flowing, but it's just a code flow, right? Top to bottom, and it's calling code, and then that code actually goes and does all the work. So your orchestration really isn't doing anything other than facilitating the orchestration. And then when it comes to what changes together should be deployed together. So put everything in the same function app that's going to run together and deploy it all together. Don't split things up into different applications if they're all going to be running at the same together. Here are my references, all the documentation. My last one here is to my GitHub repository. My contact information, if you feel you want to reach out to me about anything in this topic, I'm happy to answer any questions or help out. Yeah, so thank you so much. Enjoy the rest of the Festive Tech Calendar event throughout December. Happy holidays. Stay safe, and enjoy the break that's coming up. And Happy New Year. Thank you.